All right, we're going to go over the first part, and hopefully the microphone's working this time. Just bring it down here to get a flip. There we go. I'll run through the first part. Won't solve everything exactly, but I'll show you what you need to know to be able to solve it. So the first one here, question 1. You just need to know your vectors. So this should have been expected. I definitely told you that was going to be on there. So you should have just memorized all your vectors and scalars, or put them on your, on your study guide. So no excuse to miss the first one. The second one is all about the slope of the graph. So slope, you know, is equal to change in y over change in x. So for this graph, on the y we have change in velocity, and on the x we have change in time. So what does that equal? Well, let's go to our reference table here, and we just look. Well, change in v over change in t. So that would be your acceleration. Just looking at that equation and matching. So acceleration is the answer, because that's what that's equal to. Let's see, question 3. A lot of these are just about listing your variables. So what is your final velocity? So VF equals question mark. If a bird that is initially traveling at 10 meters per second, so VI equals 10 meters per second, and accelerates at 3 meters per second, so A equals 3 meters per second squared, over a distance of 10 meters. So now what you do is you look at your 3 options. Well, which one uses VF, VI, A, and D? Oh, excuse me. It is this bottom choice here, because it doesn't have T in it. So you have VF squared equals VI squared plus 2AD. And then you just simply plug in. I'm not going to plug in and solve every question here, but these are the numbers equal to those variables you can plug in and solve for question 3. Oh, this is just one version. There was multiple versions of the test, so your numbers may be different. Equations are all the same, but the numbers may be different. Next question, how long? I'm looking for time. T equals question mark. Does it take a car to travel a distance of 10,000 meters? If it has a constant velocity, so this is not initial, this is not final, it's just your velocity. It doesn't change. So now I need an equation that has V, D, and T in it. So it's going to be the first one we learned. And that has a line, which of course means average. But the average of a constant number is just the constant number. It doesn't change. So we get 30 equals 10,000 over T. So the next one, what's your acceleration? A equals question mark. If it takes a time of 0.25 seconds to change your velocity, so remember, that means change. Delta means change your velocity by 5 meters per second. So again, same process. Find one of these equations that has A, T, and delta V. It's your acceleration equation there. So you're going to use A equals delta V over T. If I'm going too fast for you to solve these, just pause the video. So question 5 done. A third of the way done. Cruising along. Cruising. Question 6, similar to question 1, which is asking about a scalar. Again, memorize them. So this would be choice D, temperature. What is the final velocity? Okay, so VF equals question mark. Oh, question 7, I gave the star. This one's tricky, because it says if it's dropped. So here you need to know that drop means your initial velocity equals 0. We're not throwing it down. We're not tossing it up. We're just holding it there. It's not moving. And then releasing it. So it's starting at 0. So VI equals 0 meters per second. And it takes a time of 3 seconds to hit the ground. And the last thing we have to throw in there is our acceleration. So all the bridges and the ground here, we're clearly referring to Earth. So we're going to use negative 9.81 meters per second squared as our acceleration. So we have 1, 2, 3, 4 variables. Grab the reference table. Which equation do we use? Well, we want the equation that doesn't have displacement in it. So it's going to be the first one here. So we're going to use VF equals VI plus A times T. Plug in and solve. Question 8 is a trend we should have memorized. So we have Earth here. what happens to the magnitude of the acceleration due to gravity as we get further away? And it's going to decrease. And that's just something you need to memorize. The idea is that Earth is the thing creating the gravitational pull, which is causing objects to accelerate. So the closer you are to the source of the gravity, the more of a value, the higher the value of the acceleration that you'll get. If you got closer, it would increase. This one was asking about getting further away. Question 9. What is the acceleration? So acceleration equals question mark of a runner that has an initial velocity, okay, VI equals 4 meters per second, and reaches a final velocity, okay, VF equals 8 meters per second, in a time of 6 seconds. So again, you've got 4 variables. You want to look at 1, 2, 3, 4. Which equation has those? It's going to be VF equals VI plus AT. Plug in and solve. Question 10, I think, is another tricky one. How far, so we want displacement here, does a rock fall if it was, dropped? That's the second time it came up, so VI equals 0. If our initial velocity is 0 meters per second near Earth's, why Earth's surface? Well, because the acceleration is equal to negative 9.81 meters per second squared on the Earth's surface. So we're going to use that. And it takes that time. So t equals 0.35 seconds. So the equation we want to use, well, let's see, we have d, vi. We don't have vf. So this equation here, the second one, is the only one we have that doesn't have vf. So we're going to use d equals vit plus 1/2 at squared. This one's tricky. Make sure you don't forget to square. Make sure when you do 0 times t, you drop it and it goes away. But yeah, plug in and solve for D. All right, question 10 done, 2/3. Question 11. So we want the one as it moves from left to right that has the positive acceleration, which means the dots should be getting further away. So these dots are all equally spaced, which means we have 0 acceleration. These are getting further away, which means we're getting faster and faster, which is a positive acceleration. So we want choice Y. And of course, looking at this one, these dots are getting closer and closer together. So that would be a negative acceleration. We're slowing down. Question 12. How far? Okay, so we're looking for displacement. Does an object travel it accelerates at 3 meters per second squared? For 2 seconds, that's a time. Time equals 2 seconds. And has an initial velocity of VI equals 12 meters per second. All right, same process. We're missing VF. Let's use the equation that doesn't have VF. So D equals VI times T plus 1/2 AT squared. Plug in and solve. Pictures useful. All right, 13. What is your final velocity? VF equals question mark of a basketball that is, there it is. Time number 3, dropped. VI equals 0. So initial velocity equals 0 meters per second from 2 meters above the ground. So it's going to fall down 2 meters. I'll make it -2. The ground, where it's that, also called Earth's surface. So A equals negative 9.81 meters per second squared. If you didn't make this negative, it's okay. The equation we want to use is VF squared equals VI squared plus 2AD. What will happen is you'll get a negative when you go to take the square root. But just ignore that, I guess. So negative because it's going down, it's being dropped. Plug in and solve. All right, this next one, you're kind of just adding up positive for the east and negative to the west. But if you want, you can make like a number line. So you call this like 0, and you call this like 5, 10, 15, 20, 25, not drawn to scale, 30, perfect, not drawn to scale. Sorry about that. And we'll call this way east to the right. So we start here. The first thing we do is move 30 east. Sorry, it's not drawn to scale. So we've done that. Now we go 20 yards west. So 5, 10, 15, 20. So now I'm here. Then we go 10 yards east. 5, 10 yards east. And finally we go 15 west. So 5, 10, 15 west. So I end up here. So I end up a total of 5 yards east of where I started. And the last question, Give it the old flip. Ooh. What's the slope of this graph give you? Okay, well, just like the second question here, slope is equal to change in y over change in x. So what's on the y? We have change in displacement divided by change in t. So displacement divided by time, that gives us velocity. So the answer, of course, is velocity. All right. Well, that is zoomed in. There we go. Get out of here. That is the answers, or how to solve, maybe not the answers, but that's how to solve all of part 1. I'll post that in one video, obviously, because you're looking at it. Check my page for the answers to part 2. Thanks.